Okay, in 3.5, we're going to take a look at solving systems of linear equations with augmented matrices. Two objectives: classify and identify matrices, and number two, solve systems using augmented matrices. Taking a look at the first objective, identifying and classifying matrices. We got to know what a matrix is. Matrix is simply a rectangular array of numbers. In other words, it's a way of organizing your information. Think of an Excel spreadsheet. That would be the same, made up of cells, which we call, each cell would be made up of elements or these entries. A matrix is identified by its order. What we call the order is really its dimensions. And we always go row by column to identify its dimensions. And so if you look at the example down here of matrix A, it has 2 rows and 3 columns. So remember, rows go this way and columns go this way. And so if you can take a look here, we got 2 rows, 3 columns. The way to remember this is, for me, is remember RC cola. It's got to be RC in that order. Usually when students make a mistake, they do it column and then row. But we want row then column. So to identify what this matrix A is, it's A, and its order is a 2 by 3. And that's what you can see down here. A is a 2 by 3 matrix. That's its order. So that's going to be identifying a matrix is depending on what its order is. Also identifying is we're going to be sort of locating or identifying the elements of a matrix. So in other words, what are the cells made up of? What are the values found inside of a matrix? And so we look here at a matrix. This is a 2 by 3 matrix. And notice that each entry, there's 6 entries here, those are each called an element. And so we want to identify those elements by their location. It's like an address. And so when we say something like little a RC, and so what the little a represents is we're calling on the matrix A. Little a represents a location, big A represents the entire matrix. So the big matrix A, and I want to know what is the value, what is the element, what is the entry found in a certain location. The location is going to be RC. Again, if you look at arc, you can remember it with the word arc, but it always goes row then column. So if you look at the example here, A, and then you have subscript 1, 2, or 12, A sub 12, what we're looking for is row 1, column 2. Row 1, column 2, what value are we calling upon? Negative 9. Negative 9 is the entry for that location. And so I may say something like A of 11, A sub 11. And what is that location? Well, it's row 1, column 1. So you get 5 as your answer. Try this one and pause it, and then come back and see if you're right. How about A sub 23? A sub 23. Well, hopefully what you got was row 2, column 3. Row 2, column 3. Hopefully you got the answer of 0 for that one. So really what we're doing is identifying each element in a matrix. What a matrix is made up of an order, row by column. And then inside the matrix we have these locations or addresses for each element. You can see that with Excel spreadsheets is, each cell has a location, A1 or B2 or whatever it is, and we can either put numbers in there, we can put names in there, addresses or whatever we want, and then we call upon them. That's what we're doing here inside of a matrix. So that's the same kind of thing. It's an array of elements. Each element has an address, and sometimes we will call upon that. Now, the tricky ones may get something like this, so try this one real quick. See what you at least think it would be. And if you have something like this where I call upon the third row, the third column, notice there is no third row. So this one, there is no value. You'd say no solution, no value, does not exist, something like that for that one, because there is no third row. There's only 2 rows. There is 3 columns, but we're looking for some value over here that doesn't exist. And so that would be the address would be no value, no solution. So these are the type of problems you'll first start out with your assignment. And with the test, these are ones that you want to lick your chops on, because they're pretty easy as long as you remember it goes row by column. Let's look at an example. This would be sort of like what you'll see on your assignment test. Here's A. This is what the matrix is called, is A. And notice, first off, it says what's the order of A. In other words, what's its dimensions? And it goes row by column. So how many rows do we have? 1, 2, 3, 4 is how many rows we have, and how many columns? Well, 1, 2. Remember, columns go up and down, rows go left and right. So this is a 4 by 2 matrix. That's what we would name is A, and then 4 by 2. A lot of times you'll see it sort of down like this, and so that's how you would label sort of A, and then a subscript of 4 by 2. But that's its order, is what it is. Now we can ask about some addresses. Let's see what values are found in, like, let's say A sub 32. That's the first one we have here. A sub 32 is row 3, column 2. So we go, well, which one's row 3? Well, right here's row 3. Which one's column 2? This one's column 2. Where do they overlap? Right there, 0. Our location for that, our value for that is going to be 0 for a sub 32. Let's take a look at the last one. Again, pause here and see what you get. But a sub 11. If you want to figure out what that is, again, what it is row 1, column 1. That's our first entry, is a sub 11 is our first entry. And what's our first entry? Should be 5 in this case. So we look and it is 5. So again, we can call upon a sub 41. Again, that would be -5. A sub 22 would be 6, and so on. If I called something like a sub 23, okay, if I gave you one like that, just a real quick review, what we have here is second row. So there's our second row, but third column, there is no third column. In other words, this does not exist. Okay, there is no value, there is no solution. There's nothing that comes back to us from that array. So what we have is we have a matrix is a array of elements, a linear array of elements, these numerical values, and each numerical value has an address that we call upon. It has by row and column. The order of a matrix is also by row and column. And so when you start talking about what a matrix is, we want to use its order to describe it. From there, not just identifying, but that's going to be a big part. We're also going to move on to solving these systems. So this is where we're going to spend most of our time, is solving a system using an augmented matrix, what they call an augmented matrix. So first off, that word is a new word probably for many of you, augmented matrices. What it is a matrix. It's an array of values. You can see it down here. It is a matrix, but it's specifically designed to solve systems. Some matrices are just data containers, just like an Excel spreadsheet or a database. Here what we have is this should allow us to solve a system. And so you can see the system over here. This is what we're used to, is right here. And then what we can do is we got to learn first off, how do I convert this over to an augmented matrix? Okay, how do we do that? It's not real hard, but you got to get used to that. And then from there, how do I solve that augmented matrix? And so we'll talk about that. And again, what this is a tool to organize the coefficients of a system. Notice what we're doing is there's no x's, there's no y's. We've taken the equal sign out. In our augmented matrix, there is no variables now. And that's pretty a good thing for most students because they do feel pretty comfortable with numerical values, with integers. Even with fractions, they can manage without the variables. So what we do is we take out the variables, we bring them back in at the very end, and we're going to end up using the second one more so than this one. So a line's okay. Some teachers teach it that way. Some textbooks do it that way. I'll end up using more of a dash line. That's just what I'm accustomed to. And so either would be perfectly fine. So moving on, again, past what is an augmented matrix is really what is our goal, what are we trying to accomplish. And so what we're trying to accomplish is we're trying to create ones on a diagonal and zeros below them. Now I'll show you what that means in just a moment. Here's some vocab words that you're not going to have to know, but I'm going to use. So this word Gaussian elimination. There's a mathematician named Gauss, obviously coming up with this type of elimination with matrices. And so we call it Gaussian elimination. And then our end result is what they call a row echelon form. Okay, what they want to put it is in row echelon form. And so we'll talk about that as well. But again, those are more vocab words for when you get to, let's say, college algebra. But I want you to at least be exposed to those vocab words. So we're going to use Gaussian elimination and put it in row echelon form to solve these systems. Now, I mentioned that we need ones in the diagonal. So that if you take a look here, row 1, so here's an augmented matrix right here. And our goal is to get 1 in the first entry, in 1, 1, in subscript 1, 1. If we call this matrix A, then I want A sub 1, 1 to be a 1. Okay? And we'll have to learn, how do I do it? If it's not a 1, how do I make it a 1? But that needs to be a 1. From there, I go straight down. I always go column by column. And if you can see here in red, always complete an entire column before moving on. So I'm going to go column 1. I find the 1 first. That's step 1. Find the 1 first. Then what I want is I want zeros below it. So every value below the 1 is a 0. So I need to make this a 0. Now, and I'll show you how to do that in a little bit. Okay, so I need to show you how to make 1s and how to make zeros. That's really the two things that you need to know how to do. How to make 1s, how to make zeros. Once I'm done with row or column 1, I'll move to column 2. And what we want is we want 1s on the diagonal, so I need a 1 here. Now what that creates is sort of this triangle, and this is what they call row echelon form, right here. Okay, there's a triangle, and then what we have is we may have a number here, and we have a number over here, and we have a number over here. We don't know what those are, just some kind of constants. Okay, but what we have is our goal is to get 1 on the diagonal and 0s below that. Now, for us in Algebra 2, we're only going to do 2 by 2. We're only going to do the ones that we've really been doing a lot of with elimination and substitution. However, if it is a 3 variable, x, y, and z, then you would look something like this. 1 with 0s below, 1 on the diagonal with 0s below, and then 1 on the diagonal. And then again, it would be filled with numbers. And that is called Gaussian elimination, and we're putting it in what they call row echelon form. There's another type of elimination called Gauss-Jordan elimination, and you put it in reduced row echelon form. Those things would be things that you're going to encounter once you get to college algebra. For right now, what we're going to do is we're going to put things in what we call row echelon form. There's your triangle. 1s on the diagonal, 0s below. That's our goal. That's what we're trying to get to. Now, the whole reason why we're trying to get to that is if you look here, each column represents x's, represents y's, and this represents our constants, with the dashed line representing our equal sign. So I'm going to go and take a look at converting one back again. So if we look at one, let's say right here, and we want to convert it over, our conversion would look like this. First off, everything needs to be stacked up, where you have the x's, the y's, and the 10 and the 5. So everything needs to be in standard form. And so to convert, put equations in standard form. Now, once you put them in standard form, now you can fill in the values without the variables. So what we have is we have a 2, we have a positive 4, our equal sign becomes the dashed, and we have a 10. You see that this represents the x, this is going to represent the y, and this is going to represent my constant, and I got my equal sign right there. So the 2 is my x in the first equation, the 3 is my x in the second equation. Negative 4 is my y, and negative 5 is my c. And so what we have is we have these, there's my matrix. That is my conversion from a system of linear equations into what we call an augmented matrix. The first column represents x's, the second represents y's, and the third represents c's. Now we're going to come back to this in a little bit and actually finish it off, but I wanted to show you how to convert from a system into an augmented matrix. Now if we go back to what we've been taking a look at here, okay, what our goal is to get the 1s in the diagonal and 0s below. And so we go, well, how do I end up doing that? Well, it's through this idea of row operations. There's 3 row operations you can do. The first one is you can interchange one row with another. So I'm going to eliminate all of this here and take a look. Okay, what I mean is this: if you have like 2, 3, 4, and this one's 1, 2, 8. Well, I want this 1. Man, wouldn't it be nice if that 1 was up here? So I can take this entire row, which if you remember, the entire row is simply an equation. I take the entire row and I can interchange or switch with it in the first equation. So the second one becomes the first, and the first one becomes the second. So that is called a interchange from one row to another. You can do that anytime because it doesn't matter what order the equations are written in. But now I've achieved my 1. That's one way of looking at it. So you can do any kind of row interchange if you need to. Sometimes you won't need to. You won't use that one a whole lot. You'll use a lot more of number 2 and number 3 because that's how you get your 0s and your 1s. Now, number 2 of the row operations, a row can be multiplied by a constant other than 0. We can't do 0 because otherwise it eliminates everything. So, or division. I should put multiplied or divide. Okay? Because actually many of you are going to probably end up dividing quite a bit here rather than multiply just because of the way it's set up. So let's look at a real quick equation here. If I gave you something like this just to set up, and I want the 2 to be a 1. Okay, that's what I want. I always start first column, and I want to make the first column, first row, a 1. So we ask ourselves, how do I make a 2 a 1? Well, hopefully what you're saying is I can divide that entire row by 2, or multiply by 1/2. And in doing so, look what happens. If I take row 1, and technically how you would write it is this: row 1 divided by 2. Or you can put row 1 times 1/2. But if I divide that entire row, and you just got to do it to everything, then that's my first equation now. And so that's perfectly fine. Now I have a 1 where I need it to be. Again, our goal is to try to make a 1 here and a 1 here, with that being a 0. That's our goal. And we always go column by column. So I am a third of the way done. I've got my 1. I need to make the 3 a 0. And we'll talk about how to do that. That's the hardest of the steps, is making the zeros. But we'll talk about that in a moment. Okay? Once I make the 3 a 0, then I come down here and I'll need to make this value right here, which is location A22. I want to make it a 1, which in this case, if I had to make an 8 a 1, I would divide by 8. But don't do it now. We got to go column by column. If you change this now, that's going to mess up your 0 over here. So we don't want to change it until we get the 0. And so we want to go column by column, find the 1s on the diagonal. And then the last one is 2 rows can be added. We'll see that when we create our zeros. We'll use 1 row to manipulate the other row. Now here's some examples of matrices that are already, one that's already in row echelon form and one that's not. So here's an example. Do you see the triangle right there? So that one's done. Now once we get here, we still got to interpret what it means. If we recall, this one means x, this one means y, and this one means z. Now you guys won't have to do 3 and x, y, and z. You'll just do x and y's here in algebra 2. But eventually you'll have to do x, y, and z's. That'd be a great bonus, is one that's a triple. But if you notice here, I have 0 x's. There's my x. I have 0 y's. I have 1 z. 1 z equals, remember the dash means equals, 3. Look what that's done. This equation right here has solved for z. Z is 3. Now what we can do is we can back substitute it in. So let's look at this one right here. Here's my 2 variable equation, which technically is just 1 variable, because look, this was just a coincidence, but y is 2. Because I have no x's, I have no z. So this one, y is 2. If there was a number here, let's just pretend there's a 2 there. Then what I would have is I'd have no x's, I'd have 1 y, I'd have 2 z's equal 2. I'd rewrite this equation. No x's, 1 y, 2 z's equal 2. But I know what z is, I can plug it in and I can solve for that missing y, and that's the back substitution. So normally what you would do is once you find 1, you back substitute in, and then you back substitute in, just like we've been doing with really everything else. This one just happened to be that x and y are both isolated. So I'm going to get rid of that 2 again. That way you can see the 0. Okay, so y is 2, z is 3, and now we can go ahead and we can look at the x. So let's write this equation right here. Okay, you try real quick and then pause it real quick and then see if it matches up. What you should have gotten was x plus 9y plus z equals 1. That's the equation to the top row. Each row is an equation. Now I can substitute in for my y, I can substitute in for my z, and you get x plus 18 plus 3 equals 1. And go ahead and solve. And you get x is negative 20 as your answer. You can do 21, subtract 21 from 1, and you get negative 20. So there's our 3 answers using an augmented matrix. So going back to what our objective is here, is that we're trying to create a 1, 0, 0, or for you guys, since we're just doing 2 by 2, a 1, a 0, and then a 1 here. Why? Because now I know what y is equal to. It's going to be equal to whatever number is right there. And if I know what y is, then can't I just back substitute in one of the equations and find what my x is? So our goal here is to find what y is, back substitute and find x, boom, we're done. Gauss-Jordan elimination using reduced row echelon form would force you to make a 0 here, and now we know what y and what x is without back substituting. And so that's called Gauss-Jordan elimination with reduced row echelon form. And really, once you get used to finding zeros, you find your 1s, you find your 0 on top, you can do Gauss-Jordan anytime you want. It's just something that we're not going to spend the time doing necessarily now. You'll get to see it later down the road. Okay, now moving on and taking a look at these row operations. How do we achieve the 1s and 0s? We've already looked at the 1 a little bit already, but let's go ahead and investigate it a little bit more. So here's an augmented matrix that we're going to go ahead and take a look at. And first off, our system is going to be the opposite of x, plus 3y equals 10. And then your bottom equation ends up being 4x plus 2y equals 16. So there's our system that we need to end up solving for. And from there, we need to go ahead and set up an augmented matrix. So that's good practice. So let's go ahead and do that. Let's set up our augmented. So what we have is we have everything set up properly. Notice it's both in standard form. The x's are stacked, the y's are stacked, the constants are stacked. That is the correct way of writing your system, just like elimination. Now what we want the coefficients. So the variables really don't matter. So if you can sort of just ignore, I could almost just sort of put a little rectangle possibly to show you to ignore them. But that's what we're doing, is I'm coming over here and just having you ignore the variables. So what we have is -1 and 4, and then we have +3 and 2, and then we go ahead and write our 10 and 16 on the other side. And so it ends up looking a little bit like this. -1, +3, there's my equal sign, and then 10. And then what you have is you have +4, +2, and a +16. And so what we have now is we have our augmented matrix set up. Now remember what our goal is. Our goal is to go column by column. So we're going to start with column 1. And my goal is to make a 1 in the upper left-hand corner, and then I want a 1 on the diagonal. So this needs to be a 1. So you need to be asking yourself, how do I make -1 a +1? Well, hopefully what you respond to is through multiplication. If I multiply this first row by -1, in other words, change the signs, that becomes a +1. So now my new matrix, by doing that, becomes +1, -3, and -10. That's called a row operation. And then my bottom row doesn't do anything. I didn't do anything to it. I just made the top one a 1. So we were successful. Now I'm still with column 1. I need to make the 4 a 0. So that's going to be our next step. I just wanted to make sure to show you on this problem, how do I make the first value a 1? Let's say instead of a -1, let's say it was flipped and there was a 4 up here. Okay, so just real quick, just a good practice. What if I gave you it in reverse and maybe you didn't change the order? How would I make a 4 a 1? Well, again, hopefully what you're saying is you take row 1 and you divide by 4, multiply by 1/4. So what you end up getting is you end up getting 1, 1/2. Yes, there are going to potentially be fractions, so don't panic. Okay, and then 4. Okay, so I divided everything up here by 4 to get my new first row. And then again, my next objective is to make the -1 a 0, which we're going to look at next. So we got to make that first one a 1. Now we've got to put the zeros below. So this is how you make 1s. Use multiplication or division in order to achieve a 1. So keep that in mind because we got other ones to find. But let's go ahead and take a look at how to find zeros. Now this is the hard part, to find zeros. To find a 0, we're going to use the row with the 1 in it. Now, if you take a look back at the problem we just had, here's the problem: the opposite of x plus 3y equals 10, and the second equation was 4x plus 2y equals 16. So let's look at that one again. We go ahead and set up our augmented matrix. This is good practice again. You can try it, pause it, make sure you set it up right. Okay, what we have is we have the coefficients -1, 3, 10. On the bottom equation, we have 4, 2, and 16. Okay, that's where we're at. Again, we talked about I need to make this a 1 to start. I start with column 1 and I need to make the 1. So I'm going to multiply row 1. There we go, pin. Row 1, and we multiply it by a -1. And so if I do that, I've got our new matrix that we had just a minute ago. We have 1, -3, and -10. My bottom row is 4, 2, and 16. Now, some students may say, could I divide everything by 2 down here just to simplify it? Absolutely. That's a row operation. You can divide or multiply any row by whatever you want. Because remember, a row is an equation, and as long as you do it to everything in an equation, you can multiply equations by whatever you want. So you could divide everything by 2 if you wanted to here, but you really don't have to. Let's just leave it as it is. Now what we want to do is we want to make the 4 a 0. Now hopefully what you're thinking is, well, could I subtract 4 from 4? Yes, or in other words, add a -4 to it. But where am I going to come up with this -4? Well, if you look up here, we're going to use the row with the 1 in it to assist us. Now I'm not going to change row 1. And for some, I tell them, just go ahead and write row 1 again over here, okay, into our new matrix. Because we're not changing it. I'm simply just borrowing it. I'm going to use it to help me make that a 0. So I bring that equation over here, and I need to make this 1 a 4. Because think about it, or excuse me, a -4. If I had that 1 to be a -4, couldn't I add these two at that point? So I'm just going to do a row operation, which is a multiplication, and I'm going to multiply the top equation by negative 4. So what we're trying to do is we're going to multiply the row with the 1 by the opposite, because we're just going to use addition here in algebra 2. We're going to multiply by the opposite of what we're trying to get rid of. So you're trying to get rid of a 4, we're going to multiply by a negative 4. So what I get is I get negative 4, I get 12, and I get 40. Okay? And again, how did I get that? I multiplied it through. My bottom equation stayed the same. Again, I haven't touched it. And now I can add those two. So notice there's my 0. Sweet. Okay? And then I get 14, and then I get 56. Okay? So I added everything just like you did with elimination. That's exactly the same thing we did with elimination. We wanted the coefficients to be opposite so we can add. But now my new row is actually row 2. This new row is my row 2. Now, if you have questions on why didn't the first row change because we multiplied by negative 4, well, couldn't I just immediately go back and divide the first row by negative 4? And that takes me back to 1, negative 3, and then negative 10, okay, which I need to carry over here. And so the first row does not change. We're just using it to help us with the second row. Now look at the first column. It's done. All I've got to do now is make the 14 a 1. And if you go back a screen, let's go back one real quick. How do I make things 1s? Well, I use division or multiplication. How do I make a 14 a 1? Well, wouldn't I take this second row and I would divide by 14? 14 divided by 14 is going to be 1. And so run a little bit out of room here. But now we have once we do that, we have 0 divided by 14 is 0. 14 divided by 14 is 1. 56 divided by 14, if you do the math, should be 4. So it worked out really nice. Now look at what we have. We're done. There's your row echelon form. What does it mean? 0 x's, 1 y. Okay, I don't even need to put 0 x's. I have no x's. I have 1 y. And what does that y equal? 4. I have found my y. What do I do to find my x? Back substitute. You can come all the way back up here to the beginning if you wanted to. Plug it in. You end up getting 12. You end up getting negative 2. The opposite of negative 2 is 2. So you end up getting x is 2 and y is 4. And you check it. 8 plus 8 is 16. It works in both of them. Okay, so what we're doing here in algebra 2, we're going to use augmented matrix to find our y, and then we're going to use back substitution to find our x. And you can back substitute in either one of the original equations if you don't want to back substitute into the matrix. Okay, either way. Our goal is to get to that final solution of 4. Let's take a look at a problem. We've already converted it over. So now let's go ahead and take a look at how to solve this really quick. And again, pause it and try some yourself because I'm going to go fairly quickly through this. Step 1, I need my 2. I'm going to be working with row 1, or excuse me, column 1. So I need my 2 to be a 1. So what I'm going to do is I'm going to take row 1 and I'm going to divide it by 2 or multiply it by 1/2. So I end up getting this. I get 1, 2, 5. I divided the whole row by 2. The second row I haven't even touched yet. Okay? I've achieved my 1. I need to make a 3 a 0. What do I do to make zeros? I use the row with the 1 in it. So this row right here, I'm going to borrow. Spread that out just a little bit. Okay, so 1, 2, and 5. I'm going to use it with the second row. Okay. I need to get rid of the 3. In other words, this 3 needs to be a 0. So I need to think, what would I multiply 1 by to get rid of a 3? Well, it needs to be a negative 3. I need to do the complete opposite. So my first row becomes negative 3, negative 6, negative 15. My bottom row stayed the same. And now if I add, does that not look like elimination? Hopefully it does. It's just that we have taken out the x's and y's. Is what we've done, the equal sign. Now I go ahead and I add, and I get 0, negative 10, and negative 20. That's my new second row. So if I go ahead and write my matrix now, I have 1, 2, 5. Remember, I just used or borrowed the first row. It did not change. I just used it, and then it went back to where it was at the beginning, because I cannot lose my 1. But it allowed me to get a 0 right there, which is what we need. That was the hard part. Now we go back to an easier step, which is I need to make, now I move on to column 2, and I need to make this a 1, so I can get my 1s on the diagonal. I take row 2, and wouldn't I divide by negative 10? Anything divided by itself is 1. So my first row I haven't touched. Okay. The second row, 0 divided by negative 10 is 0. Negative 10 divided by negative 10 is 1. Negative 20 divided by negative 10 is 2. Yip hip hooray. Here we go. Y equals 2. Back substitute in. You can do it where you want. If I go back to the originals, you can. You can go back to this equation right here. This is x plus 2y equals 5. This first row. So you have a lot of places you can back substitute it in, depending on what you feel comfortable with. But I know y is 2. If you plug 2 in, let's say into the bottom one, you get 3x minus 4 times 2 equals negative 5. You add 8, and you get 3x equals 3, and x equals 1. So you get the order pair 1, 2. And you can check that, and it'll work. You end up getting 2 plus 8, which is 10. It works in the first one, and we got it from the second. So 1, 2 is your solution. Now, I know you may be sitting there going, why wouldn't we just use elimination or something like this? Because I could just add these and get the answer. You're absolutely right. We're not going to do very complicated ones. Really, augmented matrices are designed for larger matrices, 3 and 4 and 5 variables. The thing is right now, we just want to introduce it to you. We want you to be comfortable with some of the terminology. We want you to be able to recognize what a row echelon form is and a little bit of what matrices are. So this is just a basic introduction. So most of yours are going to be really simple and not very complicated. And you're right, elimination would have been much easier. And nothing says out to the side you can't use elimination to see where you're heading and make sure your answers are the same when you're done with your matrix. That would be a wise thing to do. Let's look at a second example. Okay, again, go ahead and pause it, set it up, see what it looks like. Okay. Now, if you set it up, it should look like this: a 1, an 8, dash, 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 dash. There we go, 65. There's my first equation. My second one, 4, 7, 60. Okay, we go column by column. I start column 1. I need a 1. Woo! Look at that, already there. Okay. 2/3, that's 60, 33% of my is already done. The problem's already done. So I need to make the 4 a 0. I'm already done with that one. So what do I do to make zeros? I use the row with the 1 in it. I use this row, 1, 8, 65. I'm going to use it so that I can make the 4 a 0. So you got to think to yourself, what do I need to multiply 1 by to get rid of a 4? Well, hopefully you multiply by negative 4. You always do it's the opposite. I mean, that's what makes it easy. It's just the opposite of what's there. So your first row becomes negative 4, negative 32, and then here you got a little bit of arithmetic, so at 20, 24, 260. Okay? And then you got 4, 7, and 60. And to be honest with you, I pulled this straight off college algebra. That's a college algebra problem. Okay? Straight off their assignment. Now we can go ahead and add, and you got 0, you got negative 25, and then here when you add these two, you get negative 200. Okay, so there's our new, this is the new row 2. Row 1 does not change. I just used it. I take it right back to where it was. That's where it was. Here's my new row 2. I'm done with column 1. Now I move on to column 2. What do I need to make first? Hopefully you're thinking 1. That needs to be a 1. How do I make a negative 25 a 1? Well, wouldn't we take row 2 and divide by negative 25? Or multiply by negative 1 over 25. So what we have now is we have 1, 8, 65, 0, 1, because negative 25 divided by negative 25 is 1. How many quarters are in $2? Should be 8. And so we should get 8 here if you're not sure. Okay, you can do that division. But we end up getting 8. Now look, we're done. This is row echelon form. 1's in the diagonal, 0's below. This tells me x is 0, y is 1. What is y? Y is 8. What can I do to find x? Back substitute. How about up here? How about that one right there? X plus 64 equals 65. Subtract 64 and you get 1. Looks to me like our answer is 1, 8. How can I verify that for sure? Why don't I plug it in here, make sure it works. 4 plus 56. 56 plus 4 is 60. It works. I know my answer is 1, 8. Boom, there we go. 1, 8. The only weird ones you're going to potentially get, I mean, you can get some that are no solution. Sometimes you can get an all reals one, but again, we're only going to be taking a look here at some no solutions. The all reals would be if you get a true statement. And then again, it's the equation of the line. You'd put x comma, and then whatever y is in terms of x. But But here's a no solution example. I want to show you that at least. And so we go ahead and set it up. Again, pause it. Make sure you get the setup right. Okay. And so again, I have -2, -4, 4, 4, 8, -11. Make sure it's in standard form before you put them in. Okay. If this was written like that, it would. Okay. And so if it was written a different way, like this, you would need to go ahead and move the x over here first. But let's go ahead and go here. Now I need to make this a 1, so I divide everything by -2. So row 1 divided by -2 ends up being 1, 2, and -2. If you take a look here, just look real quick. I can make this a 0, but if I divided everything by 4, I end up getting 1, 2, -2, and I end up getting 1, 2, -11. Do you see how these are the exact same things, except the constants? That's going to tell me it's a no solution. Now, what I can also do is take the first equation and go ahead and make my 0 down here by subtracting the second equation now. Okay? There's different ways you can do it, but notice what we get. 0, 0. Notice my variables vanish. Okay? And so what I have is if you ever get a situation where you get 1, like in this case, 1, 2, -2, and then on the bottom, see how there's no x's or y's? In other words, what you have is 0, 0 equals 9. What do you think about that? False. Anytime you get false in math, what's your answer? No solution. We'll investigate more of these trickier ones in class with no solutions or maybe all reals, but hopefully you've got a sort of an idea of how to do augmented matrices and what matrices are. We'll see you later.